My name is Carson Noyes, and today I'm going to go over the 2.3 unit for Miss Darling's high school physical science class. Okay, suspensions and colloids. To determine, a solution is a very small particles does not settle out on standing. Colloids are medium-sized particles that do not settle out on standing and scatters light. Suspensions are large particles settle out on standing. An example of colloids are chocolate milk, smoke, a marshmallow, milk, whipped cream, and fog. Examples of a suspension is muddy water, oil and vinegar salad dressing. And then an example of solutions are salt water, sugar water, and orange juice pulp free. Concentration. A measure of how much solute is in a solution. Especially, it is the ration of solute to solvent in a solution. Concentration increases as the ratio of solute to solvent increases. In other words, the amount of solute increases and the amount of solvent stays the same. The concentration increases. How to describe a relative concentration? A solution that has greater amount of solute to solvent compared to another solution is said to be concentrated. A solution that has lesser amount of solute to solution compared to another solution is said to be dilute. How to change concentration? Make a solution more concentrated by adding more solute. Making a solution less concentrated more dilute by adding more solvent. Calculating concentration. Concentration equals the total amount of solute divided by volume of solvent. Example, 50 grams of salt are added to 100 milliliters of water. Concentration, solute, salt, divided by volume of solvent, water. Concentration, 50 grams salt divided by 100 milliliters of water. Concentration equals 0.5 grams of salt / ml of water. Saturation. A solvent can only hold so much solute. The amount of solute dissolved in a solvent describes saturation. Saturation depends on the solubility of the solute, properties of the solvent, and environmental conditions. There are 3 types of saturation: saturated, unsaturated, and supersaturated. Saturated is when a solvent dissolves the maximum amount of solute, we say the solution is saturated. If you add more solute to a saturated solution, the solution will not dissolve. It will settle at the bottom of the container. Unsaturated is when a solvent can dissolve more solute. We say the solution is unsaturated. If you add more solute to an unsaturated solution, the solute will dissolve in the solvent until the solution becomes saturated. A supersaturated solution is a solution in which the solvent holds more solute than under normal conditions. Supersaturated solutions are usually made by increasing temperature or pressure. Examples are soda is a supersaturated solution. It is made by dissolving carbon dioxide in water under high pressure. The pressure is maintained by filling soda in sealed containers. Okay, what are indicators and the pH scale? Hazards of acids and bases. Acids and bases are chemicals that can be dangerous if handled or used incorrectly. Weaker acids and bases are sometimes labeled harmful, which means they can irritate the skin, eyes, or respiratory tract if exposure occurs. Stronger acids and bases are labeled corrosive, which means they have caused serious burns to the skin and eyes. Indicators. Since acids and bases can be harmful or corrosive, chemists avoid touching unknown chemicals. Instead, chemists use indicators to test for acids and bases. An indicator is a substance that changes color in the presence of acid or bases. Chemists use many different indicators to detect acids or bases. 3 common indicators that are often used are litmus, phenolphthalein, and universal indicator. First, we have litmus. Litmus is an example of a natural indicator extracted from lichen, a tiny plant made up of algae and fungus living in symbiosis. Litmus is transferred onto strips of paper and comes in 2 different types. Red litmus paper, which is used to test for bases, and blue litmus paper, which is used to test for acids. So, if you test a red indicator with acid, no, red litmus paper, my bad, there would be no change. But if you do it with a base, the color would change blue. And vice versa. If you test a blue litmus paper with acid, it will turn the color red. But with a base, they have no change. PHPH, or known as phenolphthalein, is another commonly used indicator. PHPH remains clear in acidic solutions and turns bright pink in basic solutions. So if you test it with an acid, it's going to be clear. But if you test it with a base, it will turn bright pink. Universal indicators. Universal indicators is a mixture of different indicators. UI is very useful because it can turn a range of colors depending on the strength of the acid or base, as shown in the table below. So strong acids will become red, weak acids are yellow, neutral, so they're through 6 through 8, normally in the 7, which is going to be green. Weak bases are blue, and then strong bases are purple. So, a pH scale, or known as pH, will show another way of showing how strong substances are. So, if it's a 0 through 2, that would be a strong acid. 3 through 6, that would be a weak acid. 7 would be neutral. 8 through 11 would be weak bases. And then 12 through 14 would be strong bases. Some examples of strong acids are battery acid, stomach acid, lemon juice. Some weak acids are vinegar, soda, black coffee, milk. A neutral substance will be pure water. Weak bases will be salt water, baking soda, antacids, or whatever it's called, and soapy water. Strong acids would be bleach, oven cleaner, and drain cleaner. This is the end of the video.